Thanks for the invitation to the organizers to participate in this 3 codes webinar, even though we are going to be talking about 3 other things. I will be talking about this co-benefit for which I don't have the formal definition, the formal statement that Pier Paolo showed for the co-design. But I will pick up on the introduction by Nadim when he said that all of the presentations will certainly show how they have interacted with the stakeholders, and these co-DES are somehow related to this interaction. So I want to show you some of these co-benefits that we obtain out of the InTheMED project. InTheMED project that was the acronym for Innovative and Sustainable Groundwater Management in the Mediterranean. And with this title, I would say that we say it all about the content of the project. I mean, we basically wanted to do that, to develop tools for doing groundwater management in an innovative and sustainable way in the Mediterranean, and certainly taking into account bringing the stakeholders from the very beginning into the game, into the different decisions. The project was developed. It was groundwater, as the title said. It was developing 5 aquifers along the Mediterranean, from Portugal all the way to Turkey. Here you see the locations and also the size of the aquifer. There are huge ones and there are very small ones. And in all of them, the final goal that was achieved was to develop web decision support systems that should be easy to use and in principle a way for the stakeholders to try to figure out what would happen in their aquifers with after taking certain decisions regarding pumping out of the aquifer, or considering what might happen if climate change impacts the climate and the temperature and the precipitation in the future. I will just go very quickly through what I think there are 3 main tangible co-benefits that we obtain out of the project. The one I would say is the power of data sharing. Is not a new idea. It's not something that we invented. The importance of open data, open source data. I mean, all the calls nowadays require that we share the data. And but it's clear that if you don't gather data, if you don't measure, you don't know the status of your system, and sometimes you can take decision thinking that the system is in good status, but simply is that the fact is that you haven't actually observed its state. We did go through a number of countries in southwestern Europe, trying to gather as much data regarding groundwater levels that was publicly available. And we found data from Portugal, Spain, France, and Italy. And we used them to make a thorough analysis of which have been the groundwater trends in the time that they have been collected. This is basically a heat map in which you see the location. I mean, how many piezometers were in each one of the sites, and the density of data according to the period that it had been observed. There is also some indication about some decisions that have been taken, the time that the Water Framework Directive entered, and you can see that clearly the density of observations increased after that. But anyway, we took this information and we did a thorough analysis that has been already published. We eventually gathered more data from some of the countries that were participated in the project, but because they were not publicly available, we were not able to use it in our analysis. Our analysis showed in this particular case we did a trend analysis on these piezometers. And here you see the location of the piezometers, whether the trend was of a rising piezometer in blue, of a declining piezometer in red, or if it was on a stable one. And the size of the bullet would represent the number of years with information. And what you can see is that, well, there are some piezometers that certainly show a declining trend, but there are many that are rising, and a substantial amount that have been in a stable trend for the years of the analysis. And as I said, we have gotten a paper out of this in which the message is that maybe the trends are not so alarming as some people think, that groundwater is going down everywhere. Well, there are areas where it is, but not certainly in a generalized way. Another tangible co-benefit, I would say, is the power of easy-to-use decision support tools. As I mentioned, the main objective of the project was to derive or bring together these web decision support tools, and we eventually constructed one decision support tool for each one of the aquifers, in which you can basically query the model to see how the piezometer levels in the aquifer are going to evolve as a function in response of a number of possibilities generally related to climate change forecast, and also water withdrawals from the aquifer. What you can see here is the interface for this WebDSS tool, which, by the way, was developed in MATLAB, and MATLAB was aware of it and asked to highlight this model in their own website as one example of cool things that can be done with MATLAB. And this here you can see that basically you have the possibility of setting two scenarios and compare how they will look like. On the left side, we have just basically the starting point. Say precipitation coefficient 1 means we keep just the same precipitation trend as we have seen in the historical data set. Water crop coefficient 1 means that we keep the same withdrawals as we have seen. And we see what happens in December of 2020. So we run the model. There is a surrogate model that is based on a sophisticated groundwater flow model. And you get the distribution of groundwater levels in the upper left figure. Then you can change the precipitation coefficient and say, well, maybe it will rain 20% less in the future years. And maybe there will be more crops being planted. So let's assume that we increase 20% these crops, and we want to know what will happen how the levels will evolve from now until 2029, and the map that you see on the upper right will be that result. Then you can compare both maps, and you see the differences in the lower graph, in which you can see that, well, there are areas with declines as large as 25 meters, and you can take decisions about it. And you can play with those coefficients and see very quickly, I mean, in a matter of seconds, which is the result of those actions, of all those previsions. We did the same thing with, I mean, in a more abstract way, using a socioeconomic model based in a system dynamics analysis. And this also was done, by the way, that example I showed you was on the Konya aquifer in Turkey. This was also done in the Konya aquifer in Turkey. The output of that model was used in this total system analysis model to bring all the loops and all the feedbacks that the evolution of the system will have, how it will impact in the socioeconomics of the system. That is, I mean, if I start pumping too much and the levels go too deep, then maybe the cost of pumping is higher, and therefore economically may not be so interesting, and some wells may not continue working. So bringing these loops into the system, we get this other socioeconomic web decision support tool, in which we play, here just the aquifer is just considered as a whole. And when we say groundwater table, it's just some kind of average of the groundwater table on the aquifer. The number of active wells, it would be the number of active wells present on the aquifer as a function of time. The same for groundwater flows and the pump power. And here the variables that the user can play with is, say, the cost of electricity, whether there is rotation on the plants. I mean, it's mentioned there, sugar beet rotation time, the following cycle time, whether there is possibility of an amnesty for the wells which are illegal, the prohibition of new wells, whether the irrigation technology changed from flood irrigation to drip irrigation. You can play with all those variables and see how the groundwater table is going to evolve, how the number of active wells are going to evolve. Because as I mentioned, if the groundwater table drops too much, maybe then it's not anymore economically viable to continue. The pump power, you can see these and many other variables, socioeconomic variables, that will also illustrate the stakeholder what's going to happen in the system in the future. And then you can take decisions based on those. And finally, the last one I want to mention is the power of transparency. We did living labs in 3 of the 5 sites. These are some pictures from the living lab in Konya. And we certainly, I must say, we found a very large interest from the stakeholders, both the farmers and the authorities, to learn about what's going on in the aquifer, why the decisions are taken, why specific management decisions are taken. And we certainly were asked by the farmers especially that they wanted to know better. I mean, that sometimes they get too much information for the authorities that they cannot digest. So these easy-to-use tools, easy to understand support material was very important for them. We did one in the Spanish aquifer in Requena, and there was this summary, this small video summarizing that basically concluding session in which we presented the results, in which we had the participation of the Director General for Water from the Ministry of Transition, Ecological Transition, which is this guy. And we had the user community presented, and we had, I mean, there's a water bottling company who also made some presentation, people from the university. This is one of our colleagues. It was something in collaboration with another Prima project, the Water project, and it was certainly a great success. I mean, as you see by the number of people that attended this the presentation of the conclusions of these living labs and basically the outcome of the project. And this video actually was produced by the community, the users community of the aquifer that have been constructed, have been put together for that. Other co-benefits that I could mention is that we found a very fruitful collaboration, and we learned from sister projects like Water, but not only. I mean, I think all the 3 projects that were financed in section 1 on that specific call, we had several collaborations together. If you wish, we develop new paradigms like this idea of having the whole Mediterranean as a global pilot site as a result of this analysis of the data gathered everywhere, or as much as we could in Southwestern Europe. We also try to start building a common taxonomy that I think is very important, that all the documentation, all the deliverables produced by the Prima projects should be integrated into a large information management system that is easy to query and is easy to get information from the outcomes of the different Prima projects. And I must say that stakeholder involvement, especially farmers, surpass our expectation. They were really very interested on the outcomes of the project and the interest that we have with them to interact and to build our deliverables based on their inputs. And that's all what I wanted to say about this, what could be called the co-benefits, benefits derived in collaboration with the stakeholders of the project.